When we marvel at the breathtaking photos taken during human space missions, there seems to be an intriguing and baffling detail that always catches our attention: the stars are missing. These are the very stars that we can easily see twinkling in the night sky from Earth. This curious absence has sparked countless debates, with some even using it as evidence for conspiracy theories. Could it be that the iconic moon landing photos were staged in a secret film studio? Or is there a more straightforward scientific explanation for the absence of these celestial wonders? In this exploration, we'll unravel the mystery of the missing stars in space mission photographs, delve into the remarkable experiences of astronauts, and uncover the reality of what the cosmos looks like to the human eye. By the end, you'll have a clearer picture of why space photographs look the way they do and gain a deeper appreciation for the science behind them. The missing stars have often been cited as evidence by conspiracy theorists who claim the Apollo moon landings were faked. Their argument? Recreating the constellations accurately in a film studio would have been too complicated for set designers. But is this claim valid? NASA's official explanation offers a much simpler answer, one rooted in photography and the physics of light. To understand why stars are absent in these images, let's examine the role of exposure time in photography. The moon's surface reflects sunlight so strongly that it's nearly blinding. To capture clear images of astronauts and the lunar surface, cameras had to use very short exposure times. This setting prioritized the brightness of the foreground objects but made the much dimmer stars in the background invisible. Had the cameras used a longer exposure time to capture the stars, the astronauts and the lunar surface would have been overexposed and washed out. In simpler terms, it's like taking a photograph of a brightly lit street at night. The surrounding stars, though present, are overwhelmed by the brightness of the streetlights and fail to appear in the photo. The experiences of astronauts who have ventured into space provide valuable insights into the visual realities of the cosmos. Canadian astronaut Chris Hadfield, who spent time aboard the International Space Station, ISS, described his view as: Hadfield's description highlights an important aspect of the space environment. Without an atmosphere to scatter light, stars appear as pinpricks rather than the diffuse, twinkling objects we see on Earth. The blackness of space is stark and overwhelming, but stars are still visible to the naked eye, just not in the dramatic way we might imagine. Astronaut Bruce McCandless also made history during his famous untethered spacewalk in 1984. Equipped with a 140-kilogram rocket pack, McCandless ventured nearly 100 meters away from the space shuttle. He described the experience as both exhilarating and loud, owing to the constant radio chatter and the ever-present risk of collision with space debris. Yet the photos of his spacewalk evoke a sense of serenity and solitude, a lone figure drifting through the infinite void. Another factor contributing to the apparent absence of stars in space photos is the physics of light itself. On Earth, the atmosphere scatters sunlight, creating a diffuse glow that helps illuminate stars. In space, this scattering effect is absent, resulting in a much darker background. While this might seem like an ideal condition for star visibility, the lack of light scattering also means that stars appear as fainter and sharper points of light, making them harder to capture in photographs with standard exposure settings. Additionally, the brightness of nearby objects, such as spacecraft, astronauts, or the moon's surface, can outshine the stars. This phenomenon is akin to trying to see stars from a brightly lit urban area. The ambient light overwhelms the faint starlight, rendering it invisible. The idea that the absence of stars in space photos proves the moon landings were faked has been thoroughly debunked by experts. Let's address some key points. As mentioned earlier, the short exposure times required to capture bright objects like the lunar surface naturally exclude dim stars from the frame. The behavior of light in space aligns with established principles of physics and photography. There's no need for elaborate theories when the science is straightforward. Observatories and amateur astronomers worldwide have independently confirmed the landing sites and artifacts left behind by Apollo missions, further validating their authenticity. While the photos taken during space missions may lack stars, they still convey a sense of wonder and vastness. They remind us of the fragility of our planet and the immense scale of the universe. Modern telescopes like the James Webb Space Telescope, JWST, and the Hubble Space Telescope have captured dazzling images of distant galaxies and nebulae, showcasing the universe's beauty in ways that are simply not possible from the surface of the moon. Astronauts who have seen the stars firsthand often describe the experience as transformative. The sight of the Milky Way stretching across the black void, unobstructed by atmospheric interference, is a reminder of humanity's place in the cosmos. It's a humbling and awe-inspiring perspective that few have had the privilege to experience. The mystery of the missing stars in space photos is not a conspiracy but a fascinating interplay of light, physics, and technology. By understanding the scientific principles behind these images, we can appreciate the incredible achievements of space exploration without succumbing to misinformation. The stars are there, hidden in plain sight, waiting to be revealed through the right lens and perspective. As we continue to explore the universe, let's celebrate the ingenuity and courage of those who venture into the unknown. Their journeys remind us that the cosmos is full of mysteries, some of which can only be unraveled by looking beyond the surface. So, the next time you see a photo from space, remember that the stars are always there, even if they're not visible in the frame. While the absence of stars in space photos can be explained by photographic techniques, there is also a wealth of science to unpack about how humans perceive stars in space. Astronauts in orbit, for instance, report vastly different experiences with starlight compared to what we see from Earth's surface. Let's dive deeper into the factors influencing stellar visibility, from the physics of light scattering to the anatomy of human vision. On Earth, the atmosphere scatters sunlight, a phenomenon known as which is why the sky appears blue during the day. However, in space, the absence of an atmosphere removes this scattering effect, allowing for a much clearer view of stars under the right conditions. Despite this clarity, the immense brightness of nearby objects, such as spacecraft or planets, often overwhelms the dim light of distant stars. Even the human eye struggles to adjust to such stark contrasts, further contributing to the phenomenon of invisible stars. Our eyes adapt to light in two primary ways: active in bright environments, and active in low light conditions. Astronauts transitioning from the brightly lit interiors of spacecraft to the pitch-black vacuum of space require time for their vision to adjust. This delay means that, for brief periods, stars might remain invisible until the eye's sensitivity shifts. This phenomenon, called underscores how both biology and physics shape our experience of space. Let's return to the Apollo program, where the absence of stars in lunar photos became a hotbed for conspiracy theories. NASA's meticulous planning and technical limitations provide insights into why the iconic images of astronauts planting flags on the moon lack a starry backdrop. The cameras used during the Apollo missions were Hasselblad models, chosen for their exceptional quality and durability in extreme environments. These cameras were calibrated to prioritize capturing well-lit subjects, like astronauts and lunar landscapes, over the faint glow of stars. One persistent theory suggests that the Apollo moon landings were staged on Earth, with the absence of stars cited as evidence. However, this claim disregards basic photographic principles and fails to account for the technical constraints of the time. To dispel such myths, modern recreations have demonstrated how identical results can be achieved under similar conditions, reinforcing the authenticity of the Apollo imagery. In addition to the stars, astronauts encounter a wealth of visual phenomena unique to space. Here are some of the most fascinating. From orbit, the Earth is a dazzling sight, its atmosphere glowing with a thin blue halo. This vibrant display often steals the show, making the faint light of distant stars even harder to notice. Astronauts have also reported seeing faint bands of light known as caused by sunlight scattering off interplanetary dust. These phenomena, while subtle, add to the breathtaking visual experience of space travel. While human eyes face limitations in perceiving stars, modern telescopes like Hubble and the James Webb Space Telescope, JWST, reveal the universe in unprecedented detail. These instruments capture wavelengths of light invisible to the naked eye, uncovering celestial wonders far beyond our visual capabilities. Launched in 1990, the Hubble Space Telescope has provided stunning images of galaxies, nebulae, and star clusters. Its long exposure times allow it to capture light from stars billions of light years away, an impossible feat for handheld cameras. The JWST, with its advanced infrared sensors, takes star observation to the next level. By peering through dense clouds of gas and dust, it reveals the hidden birthplaces of stars, offering insights into the early universe. Personal accounts from astronauts provide a unique window into the experience of stargazing in space. Canadian astronaut Chris Hadfield, for example, has spoken extensively about the beauty of the cosmos as seen from the International Space Station, ISS. Hadfield describes the view as a symphony of light, with stars appearing sharper and more vivid than they do from Earth. The absence of atmospheric distortion reveals a side of the universe few ever witness firsthand. For many astronauts, the sight of the stars evokes a profound sense of wonder and humility. It's a reminder of the vastness of the cosmos and humanity's small place within it, a perspective that has inspired countless reflections and artistic expressions. As space exploration advances, so too does our understanding of how humans interact with the cosmos. Future missions to Mars and beyond will require innovations to enhance astronauts' ability to navigate and observe the universe. One potential avenue is the use of augmented reality, AR, to overlay navigational data and enhance visibility in low-light conditions. This technology could allow astronauts to see stars and other celestial objects more clearly, even in challenging environments. As we venture further into space, new tools and techniques will be developed to unlock the secrets of distant stars. These efforts will not only deepen our scientific knowledge but also enrich our understanding of the human experience in space. Please like, share, subscribe and comment. Thank you for watching my channel.